All right, I'd like to talk in more detail about temperature. So we talked about how Kelvin is going to be our standard unit for temperature. Kelvin is not something that most people work with on a daily basis. So I personally think in degrees Fahrenheit for a lot of my activities on a daily basis, like if I have to take my temperature to see if I have a fever, or if I am turning on my oven to bake something. That's when my brain goes into thinking in Fahrenheit. But if I'm in the chemistry lab, my brain usually goes into thinking in degrees Celsius because most of our thermometers read that. They usually do both. But Kelvin is going to be really similar to degrees Celsius, and Fahrenheit is kind of its whole other thing. So I think it's helpful to talk about this while comparing the three different temperature scales. So these are three different units that we have that describe temperature: Kelvin, degrees Celsius, degrees Fahrenheit. And if we look at them on a scale and think about absolute zero, water freezing, and water boiling, we can kind of see the difference in what a change of 1 degree means. So if we look at Celsius and Kelvin in particular, so here's 100 degrees Celsius change is the difference between water freezing and water boiling. And 100 Kelvin is the difference between water freezing and water boiling. And so what we have here is that 1 degree change in Celsius is going to be the same as a 1 Kelvin change in temperature. So if something increases by 1 Kelvin, it also would have increased by 1 degree Celsius as well. Now, if you look at Fahrenheit, though, to go between water freezing and water boiling, it's 180 degrees. So it isn't a 1-for-1 ratio at all. And so that's going to lead to a much more complicated conversion. So the other difference that we see here is going to be in the absolute zero definition. So that kind of is terrible. Sorry. I'm going to go underneath it. So Fahrenheit's going to define it as negative 459. Celsius defines it as negative 273. Kelvin defines it as 0. Absolute zero is when there is no motion in the molecules or atoms that we're looking at, that it's completely without kinetic energy. And so there's no motion. So it's something that we can approach. And we've gotten really close to it. Things get weird close to absolute zero. It's the stuff of sci-fi. But here's the thing, if we are manipulating numbers algebraically, we never really want to divide by a negative or a 0. And so defining absolute zero as 0 rather than a negative number means we never look at a gas and calculate a negative volume. And so this is why we work in Kelvin more than any other version of temperature unit. Here on the left-hand side, I have our conversion factors. So for converting between Kelvin and Celsius, it's really easy. You just take whatever degree Celsius it is and then add 273. So let's say I have something that is 40 degrees Celsius. I would add 273 to it to figure out what its temperature would be in Kelvin. So that would be 313 Kelvin. And if I had degrees Fahrenheit, I would have to do something a little bit more complicated to it, just for the fact that a degree Fahrenheit is fundamentally different in scale compared to a degree in Celsius. And so here it would be multiplying by 1.8 times that 40 degrees Celsius, and then adding 32. Which would be 104 degrees Fahrenheit. So different process, but so you can use these equations to kind of convert between the two. Sometimes it helps if we're talking in Kelvin to do a quick conversion into Celsius or Fahrenheit, whatever you're most comfortable thinking in, to kind of get kind of a check on what it would be in something familiar. kind of contextualize it.